Good afternoon, everybody. Firstly, I will introduce myself, Professor Asset Chaube, working as the Assistant Professor in Electrical Engineering Department of SND College of Engineering and Research Center, Yeola. Now, you know that from the last 15 or 16 videos, we are going for the high voltage engineering, especially. So, in the starting, what we have seen? In the starting, we have seen the breakdown in the gases, breakdown in the liquids, and the breakdown in the solids. Then later on, what we have gone? We have gone for the generation of the high voltages in high current. What we have seen in the generation of the high, between generation of AC voltages, AC current, generation of DC voltages. All this we have seen up till now, right? So what we have seen in this case, firstly we have seen what are the different methods or different instruments are going to be used for the measurement of generation of the high alternating voltages. So generation of the high voltage generations, we have seen the cascade transformers. In this case, what we have done, we have cascaded the transformer to generate the high voltages. Why it is going to be essential to cascade the transformers? Because it is essential, because we can't build up a single transformer as it is not economical, it is not going to be accessible to manufacture the generation of the high voltages. Single cannot be used. So for these purposes, we have to use the cascading of the transformer. What do we have done in the cascading of the transformers? We have done that number of transformers, or it may be more than 2 or more than 3 or 2 or 3. They are cascaded. Means once output is given to a procedure, I have used as a second input. Second input, each output is going to be used as third input. Even they are going to be cascaded. So we can generate a high voltage at the last transformer. So this is going to be cascaded. Then later on, what we have seen? Later on, we have seen the resonant transformer. What resonant transformer? Because it depends upon the principle of resonance. Depends upon the principle of resonance. We know that resonance occurs. When resonance is going to be occur? When L equals to C. It means the inductance is equals to the capacitance of that one. We have seen the series, that is going to two types of series resonance and parallel resonance. So in this case also, generation of the high voltages and current, there are also series resonant transformer and parallel resonant transformer. So this is going to be up to now. Later on, what we have seen. Later on, we also see the Tesla coils for the generation of the high voltages. Now, in this lecture, we are going for the next one, that is going to be the measurement of high voltages and high current. We have generating, no problem. But we must how to measure, because it is not possible. Generally, we are going to use the potential divider. But potential divider has a certain limitation. Up to that voltage, we can measure by the use of voltage measurement. So now, an important method is going to be we are studying today. That is going to be the spear gap meter. The spear gap, there are two spears and the gap is placed between them. And that is going to be the spear gap meter for measurement. Remember, measurement of peak AC, DC or impulse voltages can be easily done in the case of spear gap meter. You can measure peak AC, DC or impulse voltages in the case of spear gap meter. Now the question is, why it is going to be spear gap? Why it should not be rod or what the other uniform field gaps? Because in this case, the accuracy is less, and in this case, spear gap of the meter, the accuracy is more. See here in this case, spear gaps are used to measure voltage measurement. A uniform field gaps will always have a spark or voltage within a known tolerance under constant atmospheric pressure. It means When the spark core, so now there are two spheres. A supply voltage, high voltage is given, and these two spheres are brought to near to each other. As the distance decreases, at a certain distance, what happens? A spark core is going to be occurring, and at that voltage, you can see that, or you can say that that is the peak AC, DC, or the impulse voltage. So now see, spark voltage within known tolerance, and in this case, accuracy is also going to be 2 to 3%. With spark gap meter, voltage meter, we can put up the accuracy up to 2 or 3%. So that is going to be that one. The sphere gap meter are used to measure voltage measurement. A uniform field sphere gap, you know that uniform field and the non-uniform field. We have seen in the case of where we have seen this uniform field and non. I have already told that these terms will be repeated in the next topics. So here again, you must know what is the uniform field and what is the non-uniform field. How the uniform field is created and how the non-uniform field is created. I have told when I taught the lecture in the classroom. I have told what is the difference between the uniform field and the non-uniform field, and what is the importance of the non-uniform field as well as the uniform field. We always have a spark core voltage within known tolerance with constant atmospheric condition. Constant atmospheric condition means temperature is constant, pressure is constant. Hence, the spark gap will be used for the measurement of peak value of the voltage. If the, for example, G here, hence the spark gap can be used for the measurement of a peak value of the voltage. Peak value of the voltage may be AC, may be DC, or it may be impulse. If the gap, C is the example. If the gap distance is known, I already told that from the gap distance, you are going to decrease the gap distance, certain gap, at a certain gap, you can measure the gap between the two spheres. So that gap, if the spark is going to be divided by measuring that one, you can, if there is a table given, by the table you can, where in the table the diameter of the sphere is also given. So by this quantity, you can measure high easily by the spark gap meter, the high voltages of the AC, DC, or the impulse. So see here, a spark or voltage of 300 kV at a 1 centimeter spacing. Spacing it means the distance between the two spheres. AR at a 20 degree centigrade and 360 ton pressure occurs for simple gap measurement or in uniform field. So now next we will see. Just I have told you that why the sphere gaps are going to be used. Why not they see here? Only sphere gaps are used for voltage measurement. In certain cases, uniform field gaps or rod gaps. Just I have told you that rod gaps are also used, but their accuracy is less. Just what I have told you that same thing I have told at that time. The accuracy is very less in the case of uniform field gaps or the uniform field gaps or the rod gaps. So in this case, we are using why we are suppose in the examination it is going to be asked why we are using only sphere gaps. Why we are not using the rod gap? So you can easily say that the accuracy is very less in compared to the rod gap and in the sphere gaps. Speed gap meter is going to be very high. And the second advantage is that the spark gap breakdown, the sphere gap breakdown is independent of the voltage waveform. That is important. Just what I have told you, it may be AC, it may be DC, and it will be impulse. So when we are seeing AC or DC, what is the difference between them? There is nothing but a difference of only waveform. So here it is said that the independent of the voltage waveform and is highly suitable for all types of the waveform, from DC to impulse voltage of the the same thing I have told you already. That is going to be that from the advantages of why we are using the sphere gap type, why we are not using the rod type or the uniform gap type. That is going to be the way. So near see here the construction. Simple construction is given. You see here. Sometimes what happen, or here high voltage is like this is here a 4 point. There is the high voltage connection. Sometimes what we are going to use, we are using the resistance. Or resistance is going to be limiting the starting the high current, high breakdown current. So high breakdown current is limited. Sometimes we are not shown, but if you are going to see in the book, then they are going to show that the resistance is connected. So what is the purpose of to connect this resistance? To limit the breakdown current of that one. So that is going to be the here. First one, C, insulator support. Here the support is given. This is going to be insulator support. What is the second one? Spear spank. Here, see here. The spear shank. That's two numbers, spear shank. Operating gear and motor for changing gap distance. Here, 3 here. Why motor is going to be used, or sometimes it is not compulsion that motor is used. Sometimes you can use the other method. The gap distance between the two spheres can be easily controlled by this method, by this motor. So it is going to be change motor for changing the gap distance. Why is it essential to change the gap distance? Why? Because it is essential that as we are going to decrease the gap between the two spheres, a certain point will come where the spark core occurs, where the spark core voltage occurs. You can easily say that this is the peak AC, DC, or an impulse voltage. Get idea about it? Now, second one, just I have told you that. This is going to be the fourth one is the high voltage connection. Then P is the sparking point here. Yes, just I what you told, sparking voltage. Sparking is of course sparking over, then that is going to be the voltage, peak value of the AC, DC, or the impulse voltage. Then diameter of the sphere. Here, just I have told you that in the table it is given. What a parameter given? Diameter of the sphere, distance between the sphere, and the voltage that is going to be measured by that. So here the diameter of the sphere is given. Here is the spacing charge. This is spacing, which can be decreased or increased by using this motor gear. Here motor is going to be given here in this way. By motor you can decrease or increase the gap distance between the two spheres. Now that is going to be diameter, then spacing, then height of the P over the earth. Height of the earth and the A is the height of the height from the earth. So these are the simple construction of the spark gap meter. You can just remember that these are the two spheres are given. High voltage is connection. High voltage is coming through the resistance sometimes. Why? To limit the breakdown current. This is going to be very high. That's going to limit for the resistance. Here not shown, but if you are going to refer the book, then you can clearly say that resistance are also connected. And what are the advantages of connecting the resistance in this case? Now remember, in case of AC peak value and DC voltage measurement, the applied voltage is uniformly increased. Until spark core occurs in the gap. Just I have to. When the spark core occurs, you can easily say that is the peak value of that. Generally, a mean of about 5 breakdown value is taken and the average is going to be given. 5 readings are taken. After 5 readings, the average is going to be taken. So when that, we can agree that there is the accuracy of plus minus 3%. Plus minus 3%. In case of impulse voltages, to obtain 50% flashover voltage, two voltage limit differing by not more than 2% are set such that application of the lower limit value either 2 or 4 flashovers take. Right? On application of upper limit of 8 to 6 flashovers take place respectively. Lower limit 2 to 4 flashovers. Upper limit maximum 8 to 6 flashovers you can take, and taking the average of that arithmetic mean take of that one, that will give you the arithmetic mean will give you the peak AC, DC, or a impulse voltage. The mean, see here, the mean of these two limits is taken at 50% flashover voltage. That is going to be the flashover voltage for various gap distances and standard diameter of the sphere gap measurement. Views are given in the table. Just I have told you that table is given. What is given? The various gap distance, standard diameter of the sphere gap measurement. What are the made up of the sphere gap? Sphere gaps are really made up of metal. They may be aluminium, they may be bronze, or they may be copper. Always remember. They may be made up of, just we will see again right now, but it may be made of aluminium, copper, or the bronze. See here in the table, the values are given in this case of the clearance resistance is 79%, measurement to be within plus minus 3%. Now we will see sphere gap construction and assembly. Just we have seen that sphere gaps are made with two metal spheres of identical diameter D, capital D, with the shank I have shown in the diagram. Appearing gear is also going to change the distance between the two spheres. Insulator support, I have just firstly what I have shown the insulator support shown in the diagram. Same thing is going to be occurring here. Sphere gaps are used to measure up with generally made up of copper, just what I have told, copper, brass, or aluminium. The latter is used due to low cost. Cost is low, so that can be used. The standard diameter for the sphere, like this, remember, Remember this point. The standard diameter for the spheres are 2, 5, 6.25, 10, 12.5, 15, 25, 50, 75, 100, 150, and 200 centimeters. It means in this range only you can put up the diameter, standard diameter of your sphere depending upon the voltages you have to be measured. Very important. Why the different I guess that is going to be for the different types of the voltages or AC peak voltages we have to measure. The spacing is so designed and chosen that flashover occurs near the sparking point P. Just in the diagram, just see the diagram I have shown. That's the area P. Sparking point is given, that would be where the sparking is going to be occur. The spheres are carefully designed and fabricated so their surface are smooth and the curvature is clear. The surface should be smooth. They should not be dust. They should not be grease. That should be also remember that the sphere that we are using should not have dust, should not have the grease. Otherwise, you can't get the accuracy for which that spatial speed meter, sphere gap meter is used. The dimension of the shank used, grading ring used with sphere, ground clearance, it should follow the values indicated. The high voltage conductor should be arranged so such that it does not affect the field configuration. Remember, just I have told what that same point is coming. Series resistance connected should be outside the shank at a distance 2D away from the high voltage sphere or the sparking point. In the diagram, there is no sort, but I have told you already that there should be a resistance, series resistance in the case of connection of the high voltage. The irradiation of shear gap measurement is needed when the measurement of voltage less than 50 kV are made with the sphere gap measurement of 10 cm diameter or less. Irradiation can be obtained from coarse tube mercury vapor lamp of 40 watt rating.